Hello, welcome to Testing Stage 2023. My name is Mykola Panasiuk. I'm from Ukraine. I'm working as a principal quality assurance automation engineer at great tech company. And it's really a pleasure for me to be here at this conference as a speaker third time in a row. For today, I prepared for you a really interesting topic. It is called Level Up Your Approaches to Test Coverage. And a few more words about me. I have been working in IT for over than 9 years, six of them in automation. My main focus and responsibilities are automation itself, non-functional testings, in most of the cases, such as performance testing of any kind of level, and development of testing tools and frameworks. In case you will have some additional questions related to my presentation or for today's topic, you can feel free to contact me on dedicated Slack channel for this conference or simply follow my LinkedIn profile by this QR code on the screen. So, proceeding to agenda, we will speak about what is test coverage. We really need to understand what does it mean in order to work with it. After that, we will discuss how much does test coverage important in general. Of course, I prepared some practice for you, and that's why we need a demo project and to look at its structure in order to work with it. After that, we will see how to measure test coverage for our demo project. And also, I would like to discuss with you some connections between testing pyramid and test coverage. And based on all these five parts of our agenda, we will discuss the headliner of our presentation, what and how level up of test coverage. So, starting with the definition of what is test coverage itself. According to some sources, test coverage, or you may see some another title for it, code coverage, is a percentage measure of the degree to which the source code of a program is executed when a particular test suite is run. From the first sight, it may seem a bit difficult to understand what it is really about, but everything becomes clear right after looking at this screenshot with an example of some basic class. It just simply has two methods. One of them was covered by test execution, while another one was missed in our test suite. So green lines here means that the code were executed or hidden, and red lines that our code was not executed. And that's why we miss it in our code coverage report. Okay. And but the things are not so simple as it might seem on the first sight. In reality, is a bit more complicated. And in general, test coverage is an aggregated definition for a group of metrics. One of them is line coverage. We can say line code coverage as well. It's a number of lines of code executed divided into total number of lines of code in an application, and for the convenience to multiply it 100%. From the other side, we have one more metric, which is called branch coverage. And it is measured as number of branches of code executed divided into total numbers of branches of the code in an application, as well multiplied to 100% for the convenience. At the same time, we have one more metric, or one more, let's say, group of test coverage, method coverage. It's a number of methods of code executed divided into total number of methods of code in an application multiplied to 100%. So instead of just general definition of test coverage, we have three more definitions right now. So things are a bit more complicated, as I said previously. Okay, while we already a bit or less understand what does test coverage mean, we need to discuss how much does test coverage important for us at all. From one side, test coverage is an essential aspect of software testing as it helps to measure the effectiveness of testing effort. From the other side, it provides a metric to determine how much of the software code or functionality has been tested, enabling developers to identify areas that require further testing. Another statement says that adequate test coverage is crucial for ensuring that the software system meets the expected quality standards and operates correctly in the intended environment. So, like general statements about how much does test coverage important. And to be honest with you, all of the statements were generated by ChatGPT, an artificial intelligence system, which is quite famous nowadays. Okay, but let's consider the example of two different projects. Both of them are quite important for us. And let's say the first one has 80% of code coverage and another one has 20% of code coverage. I'm sure that all of you would say that the first project is much better in terms of quality, in terms of code coverage, and we can have a higher level of confidence about the quality of our product and be sure that at least we will get much less bugs inside of the project. Okay, but higher code coverage can guarantee the better quality of your software product. However, does 100% of code coverage guarantee you the absence of defects? And no manual testing at this time anymore? I would be glad to say that 100% of code coverage would lead to not having manual testing or manual test cases at all. But reality is a bit different. We still need have another test cases, manual, some end-to-end tests in our daily activities to guarantee the quality of our product. And even having 100% of code coverage can't guarantee our product to be without defects. But it leads to very straight consequences of what we already discussed. That test coverage is one of many instruments for your quality gates. It's not a silver bullet. It's not a comprehensive instrument or approach for your quality gates. But to be honest, it's one of most important instruments for your quality gates. Please remember that. And here we come to demo project structure. It was written by me on a .NET 7 platform. Actually, it doesn't matter which platform I would choose. Actually, you can do that on a Java platform, on Node.js, or even on Python. Each of the platform has its own packages to work with and approaches to work with test coverage. I prepared some test service in a classical architecture approach with data access layer, with application layer, which covers all the business logic related to this test service. It's just a demo business logic, so nothing special or complicated. And some presentation layer, which handles the communication with outer world. It can be messages, brokers, or some HTTP protocols communication or API, in other words. At the same time, we have two more projects related to tests. One of them dedicated for unit tests, which are under control of developers mostly, and another one for integration tests. And in most cases, quality assurance automation engineers are responsible for them. So you more or less understand what demo project is about, and we will see later how to measure test coverage for test series. Moving next, and now we can discuss how to measure test coverage for this demo project. I think many of you already at least had some experience with test coverage or even can suggest some approaches. But I would start with our own experience, and at first we considered to handle or to measure test coverage based on some frameworks for developing like Rider, Visual Studio, and some plugins for it. They were able to provide some results of test coverage based on test execution. At the first sight, it can be convenient to look at this detailed information, but from the other side, it's not so convenient to track the history, to get some aggregated report, to get some report for your managers, and even some team members are not so qualified to run tests and to analyze the cut coverage but still they are interested in to know the quality of your product. Another a bit simpler approach, but almost the same, is to use a terminal and to write some commands in order to execute tests. For .NET, it's .NET test command, and to add some additional parameters or options to handle code coverage and to get that results for us. For .NET, de facto standard is a package which is called correlate collector, and we simply need to add this option, and the spelling for exploit code coverage can be different. It depends on the settings file you provide for correlate collector. And to be honest, it doesn't require from you any additional piece of work. So just simply reference a package and add in this option, and everything will be handled for you automatically. So after tests are finished, we just follow this report in XML format, which is also format of cobertura. And it has everything related to test coverage results. Let's look how it's structured. Looking inside of that file, we can see a lot of XML, like not code, but some text, I would say in this case, that shows us some generated information about code coverage. Of course, it has a lot of lines, a lot of additional information, some lines information of the code, but we are interested mostly in aggregated results at this moment. And this information is located at the top of the file, like line rate. Line rate in this context, it's the same as line code coverage, as we discussed earlier. But this number needs to be multiplied by 100% to be more human readable. So line coverage in this case is about 2.3%. In addition, we have some branch coverage. In this context, it has a name, branch rate. So branch code coverage is about 9% here. Okay, a bit more convenient. We do not need to run and execute tests inside of our IDE system, but still we need to have all the stuff installed into our local host and to execute tests together to get some results. And we will see later how to improve that process. But first, I would like you to discuss with you some connection of testing pyramid and test coverage. In a classical approach, you would see testing pyramid like this with three layers. On the bottom layer or at the base, there is a unit layer or unit tests, which is responsible for business logic to cover and to test if the system behaves correctly in terms of your application. Right after that, we have integration tests, which should be much less in number than unit tests. Integration tests are responsible for checking the connection of your service with some infrastructure, some databases, message brokers, and some third-party services, and so on, or some API, like we can test also at that level. And at the top of the pyramid, we have end-to-end tests, or even manual tests we can still have. So, what is the connection really with test coverage at this moment? As you may recall, we had demo project consists of some test services projects and two more projects for tests. One for unit test, another one for integration tests. I think many of you already understood what does it mean for us in terms of getting test coverage results. We simply need to run two separate commands for measuring and executing tests like .NET test and an option for test coverage. One command for a unit test project, another one for integration test project. As a result, we will get two reports with some, I just cut a piece of report in order to show you on the slide, but still we will have two files, two XML files with that reports. And one file will have 2.3% of line code coverage, another one will have about 54% of code coverage. But reality is a bit different. In most of the cases, for me, almost always, I would like to get only one number of what is general code coverage of my project by all my test suites, like unit test plus integration tests, instead of having two separate files. Also, we will see later how to handle this approach. That's why I just wanted to point your attention on the connection between testing pyramid and our project and test coverage. So based on all we discussed previously, we can move to the headliner of our presentation and level up of test coverage. We can think on how to level up really our approaches for test coverage. First thing that comes to mind or should come to mind is to automate test coverage process. I think you would agree with me that running all the commands inside of your terminal is not such straightforward and long-term solution. And in case, for example, your project manager wants to look at the numbers. Another approach for leveling up of test coverage would be to merge test coverage result according to your testing pyramid. As I showed you on the previous slide, the connection between test coverage and testing pyramid. Just simply have one merged result. Another advice would be to visualize test coverage. We as a human like to see right away results. And it's not the best option to look at some XML files, to look by your eyes some results, some numbers, and so on. It's much better to have some colors, some well structure, some insights of on what is going on with your test coverage. So visualization is a powerful tool for you. And the last advice, but not the least, is uh, to track history of your test coverage and to choose approach and the system how to track the test coverage history for you. Let's start from the first one, automation of test coverage. On our daily basis activities in our all projects, we are using GitLab as a continuous integration system. In your cases, it can be Jenkins or even GitHub Actions and so on. Basically, all of them doing pretty straightforward thing. They simply run some Bash scripts or some Python scripts for you to execute your test. And the same was in my case. I simply had two separate projects, one for integration test, another one for unit test. And after my commit, I just had a pipeline with two jobs for each project, and they were executed in parallel. After a while, I had all my jobs done, and let's see what the information about test coverage each of that job have. One job have coverage log of the job, and with the help of approach which is proposed by GitLab, we can parse that log into a well-readable tag for our job. So we can simply see at the moment the coverage of our test service by these unit tests. So about 9%. From the other side, we have one more job, and at this moment it has much bigger test coverage in the integration tests. It's much bigger because of integration tests are communicating through the API of that test service. So basically, test execution hit more code lines than unit tests in that case. So bigger code coverage. So um, that's why it's much more here. Moving next to another advice, as I said, visualize as much as you can in terms of at least test coverage. At this moment, I prepared a screenshot of merge request, or in terminology of GitHub, it can be pull request. So actually, merge request here in terms of code coverage helps to see what was the old code coverage and what is the new code coverage after our changes. But here is one big problem here at this screen or in this merge request. I had two separate jobs, which of each of that job provides some percent of code coverage. Unit test about 13% and integration test had another percent. Percent here is different because I took a screenshot for a different branch, so not not worries here. But the problem here is this number is aggregated by averaging two values from two separate jobs. So just simply add 40 plus 13 and divide to 2. I simply would agree that this approach is totally wrong, as your code is not just simply something averaging, yes, but just overlaying some logic you can cover inside unit test or some logic you can cover in integration test. So it may overlay to each other and vice versa. And that was a problem. I will show you how to struggle with that a bit later. just want to finish with visualization approaches to test coverage. Another great option which is provided by GitLab is an ability to see what pieces of your code were covered by test execution or were not covered. As you can see, this red vertical line means that this line of the code were not covered during test execution, while green vertical lines means that other pieces of your code were executed and hit by the tests. So it's really convenient to see that difference during merge requests. Okay, as I promised, we came here to the approach of how to merge your test coverage results of testing pyramid. Remembering the structure of our demo project, we had one coverage cobertura unique XML file for unit tests and another one for integration tests. It's a point where you began thinking about some approach or a tool how to merge them. For .NET, or even not for .NET, but for cobertura format, at least we have an open source solution which is called Report Generator. Basically, it was written many years ago, but still under maintenance, so it's quite fresh and you can use it in your daily basis activities. You simply need to pass to that tool all coverage XML files in a cobertura format divided by or separated by this semicolon. And and to say which format you would like to get results. I choose to get results in a JSON format and separate HTML inline format. I will show you later what is the difference between them. And after running this command, you will get additionally to your coverage XML files, one for JSON summary and another one for HTML summary. Let's look a bit at summary JSON file. Here is just a piece of that JSON file and summary. Of course, there was a lot more lines at that file, and they are mostly related to some details. But summary is a bit more interesting here for us. Let's start from this statistic. It means line coverage was about 56%. At the same time, we have branch coverage, and moreover, we have method coverage. So all this data are a result of merging process of two separate cobertura reports. As you can see here, it helps us to understand that. Also, as you remember, we selected a report type in HTML format. It does almost the same as JSON format, but in a good visualization way, I would say. It helps to analyze code coverage of each of your classes you selected for testing towards coverage, and you can see that some of your classes even was not touched by any test execution, but some of them are covered by 100%. Okay, and after that, moving to some details which you already seen, but I wanted you to put your attention one more time. Following from this HTML report, you can choose any class you want and look at some pieces of the code and look even at lines of the code and branches. Point your attention to this sign, it means branch, which were executed and which were not executed. Red color means that that code was not covered. And as a result, in our continuous integration system, apart from these there's two jobs which we already know about, we have another test coverage job which is on hold and waits their dependencies. Integration test job and unit test job. After a while, we will have some integration test finished. It's at this moment, it really doesn't matter that unit tests are still in progress because it was waiting for some runner to be free, and that's why it took much longer to run. But nevertheless, test coverage job is still waiting for the reports from unit test job. After that, all the dependencies have finished and test coverage job has started. After a while, we will have all those jobs finished, and let's look at the results. The same merge request, but with a bit different result. Test coverage here is about 50%. By the way, I forget to mention that during this merge request, we, at least in our company, decided to show about, we decided to show branch coverage instead of any other metric we can use, like line coverage or method coverage. So we decided that branch coverage is most important among all other, as GitLab only allows us to choose one. So the previous result was 25, and now we have 50. But the more important thing at this screen is that we have results only from one job, which was handling all the results of merging from different jobs, from unit test and integration test. So right now we have correct number, not just averaging, but correctly merged results. And this slide, I wanted you to point an attention to the badges. Badges are very helpful when you just land to some demo, like not demo, some repository level and want to know the general attributes of quality for this repository. And badges shows you not the history, but straightforward numbers right and here about code coverage. And at first we were able to only get one number as it was for merge request, but with some additional work we found out a way to show branch coverage as a separate batch. Additionally, we add some line coverage and even method coverage. So it's very convenient and it's a part of visualization, as I said. And here we came to one of the most interesting topic for today is how to track history of test coverage and what approach to choose. The factor for us in visualization in terms of metrics and so on is right now Grafana. Grafana helps to visualize all these metrics by communication with some time series database which handles all our metrics. So at first we needed to save test coverage results from our job to time series database, and then we were able to build a separate Grafana dashboard, as I did for this, and to show the trends or the history of test coverage. A separate graph here shows aggregated results for branch coverage, line coverage, method coverage. Not like the aggregated by, but I mean the The most valuable data for us is represented on this graph, but point your attention to that this is related to test project for unit tests. Separately, we will see the difference for integration tests and to the aggregated job. Additionally, we have another great statistic and pieces of information related to code lines, how many total lines we have, how much we have coverable lines, uncoverable lines, covered lines, and so on. The same for branches, total branches, covered branches, methods, like total methods and covered methods. Okay, I hope it is more or less clear what does these graphs mean. And still, I would like to speak more about some parameters and some filters for this Grafana dashboard in order you to understand how helpful it can be for us. You can simply choose for which repository to show the results for you. Then you can even filter by branch you are interested in, and I'm showing the main branch at this moment. You even can choose only by pipeline ID in case you know a particular pipeline ID you would like to know. But the default value is to use all pipeline IDs we can track on the timeline, selected by time filter here. The same we can even filter by job ID. And I forgot to mention that pipeline is just a batch of jobs related together to some after some commit, and it has ID. And jobs inside of pipeline have their own job IDs. And as I mentioned already, there is a filter to choose a test project you want to know information from. And even project of what you track or what do you want to know the code coverage about. As I said, test coverage for this test service can be detailed, and you can see details for application layer, for data access layer, or for presentation layer. Another big advantage of using Grafana is annotations. We can simply click on the toggle, and right after it appears annotations. There's green lines, green vertical lines with some panel which has some additional helpful information for us. By clicking on one of these links, we can go directly to GitLab pipeline or even to GitLab job. But the most interesting thing is that we can straightforwardly get access to some HTML report by clicking just simply on this link. We will land on some Amazon S3 storage, and we can track the information about test coverage right there, just analyzing of our code. And each annotation represents each run. Each run means one pipeline or even some activity on continuous integration system right after your commit. And I would like you to point an attention to this number, let's say branch coverage 9% and line coverage 2.3% for unit tests. For integration tests, we have branch coverage 40.9% and line coverage 54.2%. As I said, it's better to get match results, and we already have that for our demo project. We can hear here all tests from this filter and statistics for coverage. which is as aggregated results from branch coverage. It was 9%, sorry, not 9, but yes, for branch it was 9% for unit test and about 40.9 for integration. So in summary, it's about 50%, and line coverage is also calculated correctly. Believe me, I checked that previously. So it's all about visualization and tracking history. We can proceed to summary. Um, I just want to say that um, please remember that test coverage is one of many instruments of your quality gates. It's not a comprehensive tool or approach. It's just one of many, but still very important for your quality gates. Remember that there are a few different test coverage metrics. Choose the most important for you. These um, stayed with some branch coverage for ourselves. And make test coverage one of your best friends and a powerful tool for your quality, not just a number somewhere. Uh, just imagine that some code coverage number died in your terminal and you the only person who knows about it. But while you have some results in Grafana, it's much more better to track, to analyze, and so on. So leveling up means to automate, to merge, to visualize, and to track the history. At this moment, thank you for your attention. I hope you liked it. In case you have some additional questions, you can contact me, and I'm ready for Q&A session. Thank you one more time. See you. Bye.